Welcome to the exciting world of physics, where we explore the magic of motion. Motion is simply the way objects move, and understanding it helps us see how the world works. In physics, we use terms like speed, which tells us how fast something is moving, and acceleration, which is how quickly the speed changes. Another important concept is force, which is a push or a pull that causes objects to move or change their motion. When you throw a ball, your arm applies a force to it, making it fly through the air. By studying these ideas, we can predict how objects will move in different situations, from a car racing down the road to planets orbiting the sun. Physics is not just a subject, it's the key to unlocking the mysteries of the universe.
Imagine invisible waves that travel through space and affect everything around us. These are electromagnetic waves, and they play a huge role in our daily lives. From the way your cell phone communicates to how doctors see inside your body at the hospital, these waves are essential. Electromagnetic waves include light we can see and radio waves we use for communication. They travel at the speed of light and vary in wavelength and frequency. The shorter the wavelength, the higher the frequency, and vice versa. Devices like phones and radios use specific frequencies to send and receive information without wires. In medicine, different types of waves help create images of the inside of our bodies, helping doctors diagnose illnesses. Understanding these waves helps us improve technology and healthcare, making our lives better and safer.
Gravity is a force that pulls objects towards each other. Albert Einstein, a famous physicist, made groundbreaking discoveries about gravity. He proposed the theory of general relativity, which explains how gravity works not just on Earth, but throughout the universe. According to Einstein, gravity is the result of objects bending space and time around them. Imagine a heavy ball placed on a stretched rubber sheet. The sheet bends under the ball, and if you roll a smaller ball near it, the smaller ball moves towards the larger one. This bending is similar to how planets and stars warp space-time in our universe, causing gravity. Einstein's ideas changed how we understand the movement of planets, stars, and galaxies, and they continue to influence modern physics and astronomy today.
Superconductors are materials that can conduct electricity without any resistance. This means that they do not lose any energy as heat, which is what happens in normal conductors like copper. Imagine electricity flowing through a wire as smoothly as a perfect ice skater glides across ice. This special property appears only under very cold conditions, typically far below the freezing point of water. Scientists are excited about superconductors because they can help make very powerful magnets for machines like MRI scanners, which doctors use to look inside your body. They can also make electrical systems more efficient, saving a lot of energy. However, creating and maintaining these super cold conditions can be challenging and expensive. Researchers are working to find superconductors that can operate at higher temperatures to overcome these challenges.
Particle physics is the study of the smallest parts of matter, called particles, which make up everything in the universe. Atoms, which we once thought were the smallest things, are actually made of even smaller particles like protons, neutrons, and electrons. Protons and neutrons are made of quarks, which are held together by gluons. One of the most famous discoveries in particle physics is the Higgs boson, often called the God particle. It helps explain why particles have mass. Scientists use large machines called particle accelerators to smash particles together and study the results. This helps them understand the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces. By studying these tiny particles, we learn more about how the universe works.
Quantum computers are a new type of computer that use the principles of quantum mechanics, a branch of physics that deals with very small particles. Unlike regular computers, which use bits as the smallest unit of information, quantum computers use quantum bits, or qubits. Qubits are special because they can exist in multiple states at once, not just on or off. This allows quantum computers to process a vast amount of information at incredible speed. They are particularly good at solving complex problems that are too difficult for classical computers, such as drug discovery and cryptography. Quantum computing is still in its early stages, but it holds the promise of revolutionizing technology by making computers much more powerful.
Imagine you are on a train moving very fast. According to the theory of relativity, developed by Albert Einstein, time on this train moves slower compared to someone standing on the platform. This idea is part of what we call time dilation, a fascinating effect of relativity. Relativity also tells us that the faster an object moves, the heavier it becomes and the more it stretches in its direction of motion. This might sound strange, but it has been proven by many experiments. The theory is divided into two parts: special relativity, which deals with objects moving at constant speeds, and general relativity, which describes how gravity affects space and time. These concepts help us understand not just our world, but also the vast universe, including black holes and the bending of light.
Thermodynamics is a branch of physics that studies how heat and energy move and change in systems. It helps us understand how things like engines, refrigerators, and even stars work. The key concepts in thermodynamics include temperature, energy, and entropy. Temperature measures how hot or cold something is. Energy is the ability to do work, like moving or heating an object. Entropy is a measure of disorder or randomness in a system. There are four main laws of thermodynamics that describe how these concepts interact. The first law says that energy cannot be created or destroyed, only changed from one form to another. These principles are not just academic, they apply to everyday life, helping to design more efficient machines and better understand the universe.
Entropy is a key concept in physics, particularly in the study of thermodynamics, which is the science of heat and energy. The second law of thermodynamics states that entropy in an isolated system always increases over time. Entropy can be thought of as a measure of disorder or randomness. For example, when ice melts into water, the orderly arrangement of molecules in the ice becomes more random in the water, increasing entropy. This law helps us understand why certain processes happen naturally, like why heat flows from hot objects to cold ones and not the other way around. It also explains why some energy is always lost as waste heat in machines, making 100% efficient machines impossible. Understanding entropy helps us grasp the fundamental principles governing energy and transformation in our universe.
Plasma is often called the fourth state of matter, alongside solids, liquids, and gases. When enough energy is added to a gas, it becomes plasma. In this state, electrons are freed from atoms, creating a mix of charged particles. Plasma glows and can conduct electricity, which makes it very useful. For example, plasma is used in fluorescent light bulbs and plasma TVs. It also plays a crucial role in technologies like plasma cutting and in medical instruments for sterilization. In nature, plasma is part of lightning and the sun. Understanding plasma helps scientists in fields like astronomy and environmental science. By studying plasma, we can develop new technologies and better understand the universe.
Optical technologies use light to create amazing tools and devices. Light, a form of energy visible to our eyes, travels in waves. These waves can be manipulated to perform various tasks. For example, lasers, which are intense beams of light, can cut through metal or be used in surgery. Fiber optics, thin strands of glass or plastic, transmit data over long distances as pulses of light. This technology powers the internet and telecommunications. Lenses and cameras and glasses bend light to help us see better or capture images. Understanding how light behaves and interacts with materials helps us innovate and improve these technologies. By exploring the properties of light, we unlock new possibilities in medicine, communication, and entertainment.
Nuclear physics explores the tiny particles at the center of atoms, called nuclei. These particles, protons and neutrons, hold immense energy. By understanding how these particles interact, scientists can harness this energy for various uses. One major application is generating electricity through nuclear power plants. Here, the energy from splitting atomic nuclei heats water to create steam, which spins turbines to produce electricity. Another important use is in medicine. Techniques like radiation therapy target cancer cells using high-energy particles to destroy them. Additionally, nuclear physics helps in diagnosing diseases through imaging technologies such as PET scans, which rely on radioactive substances to create detailed body images. This field of physics not only powers our homes but also aids in keeping us healthy.
Electromagnetism is a branch of physics that studies electric and magnetic forces. These forces are invisible, but they affect everything around us. For example, electromagnetism makes light bulbs glow and compass needles point north. It starts with electric charges, which can be positive or negative. When charges move, they create an electric current. This current generates a magnetic field, which is the area around a magnet where magnetic forces can be felt. The relationship between electricity and magnetism was discovered by scientist James Clerk Maxwell. He showed that electric and magnetic fields travel together as waves. These waves are what we know as electromagnetic radiation, which includes light, radio waves, and X-rays. Understanding electromagnetism helps us use electricity safely and harness it for various technologies.
Physics is a branch of science that explores how matter and energy interact. It helps us understand the fundamental principles of the universe. In physical chemistry, physics plays a crucial role by explaining how atoms and molecules behave. This includes studying energy changes and forces at the atomic level. Key concepts from physics like thermodynamics, which deals with heat and temperature, and kinetics, which focuses on reaction rates, are essential. These ideas help chemists understand how chemical reactions occur and how substances change. By combining physics and chemistry, scientists can predict new materials, understand biological processes, and develop technologies like solar cells and batteries. Learning physics not only enriches our knowledge of chemistry but also opens up exciting possibilities in research and innovation.
Physics plays a crucial role in understanding how biological systems work. At its core, physics explores energy, forces, and matter, which are fundamental to all living organisms. For example, biomechanics studies how physical forces affect biological tissues and organisms. This helps us understand how muscles generate force or how plants grow towards light. Thermodynamics, another important area, explains how organisms manage energy, vital for processes like metabolism. Additionally, fluid dynamics is essential in understanding blood flow in our bodies, or how nutrients move in plants. By applying physics, we can uncover the basic rules that govern life, leading to advancements in medicine, agriculture, and environmental conservation. This interdisciplinary approach enriches our comprehension of life's complexities and the natural world.